We're already down to our last sample problem. Sample problem number 3. So in the previous sample, no, sa second one, that is a circular path. Here we have a parabolic path. So na tayo skier here. Okay. So design of the ski jump shown. So this is the jump. In the photo requires knowing the type of forces that will be exerted on the skier and her approximate trajectory. If in this case the jump can be approximated by the parabola shown below, determine the normal force on the 150-pound skier the instant she arrives at the end of the jump. Point A, where her velocity is 65 foot per second, also what is her acceleration at this point. Okay, so natay trajectory here. It is nagibutang diri nga asa to. And her so we have here approximate trajectory. So given by this equation that y is equal to 1 over 200 x squared minus 200. So this is a parabolic formula. So if in this case the jump can be approximated by the parabola shown, determine the normal force on the 100. So pangitaon din nato ang normal force. So again, the normal force is perpendicular to the surface. So she arrives the normal force at here, and where velocity is 6. So yung velocity at this point is equal to 65 foot per second. So atong gipangita is ang normal force. You're also asked what is the acceleration at this point. Okay, so unsa man ni siyang acceleration? So way giingon no nga tangential or normal. So we can safely assume that this is a acceleration combined sa tangential o sa normal acceleration. So what do? We create a drawing of this one. We draw an Fbd diagram. So let's say this is our point A. So ang weight ni skier is 150 pounds. So okay, if you notice, this is in English or SI units. So we have a 150 pounds here, 150 pounds. So pounds is the measure of force for the SI unit. And then, okay, so we have the axis here, no, X and Y. Let's say this is just the X-axis and the Y-axis. What else do we have? We just have the velocity just before it left here. So let's say our velocity is equal to 65 foot per seconds. And then our parabolic formula y is equal to 1 over 200 x squared minus 200. So we were asked about what is the normal force and then how about the acceleration. Let's say this is the magnitude of the acceleration, which is equal to the square of the tangential acceleration plus the square of the normal acceleration. Remember that the normal acceleration is just equal to the square of the velocity over the radius of curvature. So sa may una na to buhaton diri, we have 150 pounds. We know that the motion is on that side, di ba? Pagawa siya diri. So this is our tangential acceleration. We have the normal force at A. So that is as given by the formula and A. Okay, so since ang movement niya is paana, therefore we have, this is like a normal, this is the normal nga axis. So at this point, imagine na to nga ng origin diri, and then we also have our radius on this side, symbolized by the symbol rho. So ang first na to buhaton, so we sum forces. So this is, we call this the normal nga axis, and then here this is the tangential kani along sa iyang direction sa motion. So we have the summation of forces along the normal axis equals to 0. So we have the normal force minus 150 pounds, which is the weight of the skier, is equal to the mass times the acceleration, right? Since ang naman sa to is weight, therefore we divide the weight with the gravitational acceleration, 32.2 foot per second squared in the English units, times this is the normal acceleration. Again, this is not equal to 0. This is mass times the normal acceleration. The normal acceleration is equal to the square of the velocity this one over rho. So our velocity, we have a given velocity that is 65 squared. So we squared just the 65 over rho. So rho, so for this equation, let's say this is our equation 1. We have two unknowns. We don't know the normal force at A and then the rho, the radius of curvature. Okay, next nga atong buhatan og equation. So it is not the binormal. So ang binormal ani nga part nga motion is on that side, so di na to siya magamit. Therefore, tong kuan og next nga summation of forces is just the what? Tangential acceleration is equal to the mass times the tangential acceleration. So sa may force along sa tangential acceleration, we cannot see any force along this direction. So what do we have? Since there is no force, o may nakabutang kung na ba siya friction or wala, sa ito pa summation of forces along the tangential component, which is this one, and this is the normal. So that is just equal to 0 is equal to mass, 150 pounds over 32.2 foot per second times the tangential acceleration. From this one, immediately we can see that the tangential acceleration is just equal to 0. So what do we need again? We need to get for the NA and then for the acceleration. So we need to get for this, but we don't have the radius of curvature. We need to get this magnitude A. We already have A sub t or the tangential acceleration which is equal to 0. Sa ato pa ang normal acceleration na lang ang acceleration nga nagpabilin at this point at A. Simo buhaton na to. Okay. Next na to button, we have the summation of forces along the normal and the tangential. So, unsa yung next na to buhaton? Actually, itong problem here is just the rho. If you remember that the radius of curvature, kung natin equation nga gihatag, that is just equal to that is quantity 1 plus square of the first derivative y prime squared raised to 3 halves all over the second derivative or y double prime. Okay, so from the given equation, we have the y is equal to 1 over 200 x squared minus 200, diba? So our first derivative y prime, that is just equal to 1 over 100 times x. So this is 0. Then our second derivative y double prime is just equal to 1 over 100. Substituting these values for this equation, then we can already get our radius of curvature because we have the two unknowns. So that is 1 plus first derivative, that is 1 over 100 times x. Okay, so pila man si x at this point. Okay, so if this is the x-axis at this point, naa siya sa origin, therefore the coordinates at point A using x and y, that is equal to 0 and then negative 200. Negative 200 ang y because this is the origin of the axis, then inaog siya. And then 0 ang x because it doesn't move from here to here or wa siya nagawason algi dire origin. Therefore, si x is just equal to 0. If the x is equal to 0, then atong first derivative is just equal to 0 when x is equal to 0. So that is just times 0 squared, then raised to 3 halves all over the second derivative 1 over 100. So automatic, this is already 0. So what we have here, you only have that the radius of curvature is just equal to this one, 100 foot. You already have the rho. Then we can solve for the normal acceleration. So our normal acceleration is just equal to square of the velocity, 65 foot per seconds, then squared over 100. That is equal to how much? 65 squared divided by 100. That is equal to 42.25 foot per seconds. Again, ang atong magnitude for the acceleration is just the normal acceleration. Sa ato pa, ang magnitude for the acceleration is just 42.25 foot per second. So asa direction ang normal force or the acceleration, this is upward, because the normal acceleration, which is towards the radius of curvature, is positive. And if you notice sa atong curve, it moves that way ang normal acceleration. Therefore, the acceleration or the magnitude of acceleration is just positive and moving upwards. Next, unsa pa gipakuha sa tuwa, we have the acceleration, and then we should get the normal acceleration. Sorry, the normal force and A. So nalaman tayo road is 100 feet. We just substitute 100 here. The 100 foot nga radius of curvature. Then we can get the normal force, which is equal to 150. We have 150 times 65 squared over 2.2 times 100 plus 150. Normal force should be equal to 346.817 newtons. Okay, so this is for our sample problem number 3. So atong ibuhat gyapon no. So first is the summation force along the normal axis and then the tangential axis. Di na to magamit si binormal axis because walay pulos or walay nakabutang nga load sa binormal axis. Here at 0 ang ato ang force along the tangential axis because there is no friction on this side and there is no shown nga kung ano masolve siya. So then from this equation, then we can solve that the tangential acceleration is just equal to 0. So ang natong acceleration is just the normal acceleration on this side. So ang 150 atong i-divide sa gravitational acceleration to get the mass because 150 pounds is a force in the SI unit. So this is the normal acceleration A sub n, that is v squared over rho. So from the third equation, we have the from the curvilinear motions. No, we have this the throwing radius for curvature is equal to quantity of 1 plus the square of the first derivative raised to 3 halves all over the second derivative. So naman tayo given nga equation nga y, so ato pa makakuha tag first derivative y and then the second derivative of along y. So para masolve na to sa radius. And then, pag substitute ang values, x is 0 because at this point, ang x is nasa origin. And then, ang y is ninaog, that is negative 200, which is wala pag yapon na kami. And then, substituting these values, this is 0, then we got that the radius curvature for this, at this point, for this gear, is around 100 foot. So, given rho, then we can solve for the normal acceleration v squared over rho. So we have the normal acceleration. And then ang atong magnitude of acceleration, it should be square root of the tangential acceleration plus the square of the normal acceleration. Since this is 0, and then naka-square ni, ato lang extract to square root, ato lang makaingon nga ang magnitude of acceleration is just equal to the normal acceleration. And then we have the already the acceleration. So we also have the radius of curvature given the rho from this equation, and we can solve for the normal force A, which is equal to 346.817 newtons, and sa module is 347. Sorry, this is not newton, this is pounds. Okay, this is SI units. So 346.817 pounds. So at this point, ang normal nga normal force along this gear is 346.817 pounds.